All right, in section 1.3, we're going to look at functions and how you create new functions from old functions. One way is to do translations. You looked at these a little bit back in geometry, and we're kind of going to extend a little bit here and look at some other stuff. So anytime you have a number being added or subtracted outside of the function, that's going to shift your graph up or down, with plus being up and minus being down. So these are going to shift vertically. If your adding or subtracting happens inside the function, that's going to, instead of shifting it vertically, shift it horizontally. Okay, now when it's inside, it's always going to be opposite of what you would normally think. Normally, minus would shift it to the left, but when it's inside the function, it's going to actually shift it to the right. If it's adding inside the function, it's going to shift it to the left. And you'll kind of see this theme. Anytime it's inside the function, it's opposite. If it's outside the function, it's normally what plus and minus would do. Some other ways we can do transformations is stretching or shrinking and reflecting functions. When there is a number multiplied in front of the function, that's outside the function. And so we know when stuff happens outside the function, it's going to be vertical. The multiplication of a whole number is going to vertically stretch that by a factor of c. If it's being divided or it's a fraction where it's 1 over the number, that's going to compress by a factor of what that is, whatever that c number is. If you go on and work in like engineering and stuff with waves, this is often referred to as like an amplitude. That's not a word you have to memorize, but if you hear amplitude, that's what compressing or stretching it vertically talks about. All right, if you multiply or divide inside the function, we know inside the function, that's horizontally. So anytime it's inside the function, it's going to be horizontally. And remember, it's opposite. So multiplying by a whole number actually compresses it instead of stretching by whatever that number is. Dividing by it or having a fraction will actually stretch it because it does the opposite by a factor of whatever that is. In working with waves or stuff like that, this is often referred to as your frequency. Again, you don't need to know that, just some extra information there. All right, so that is stretching, compressing. The other thing, if you have negatives, that's where our reflecting comes in. So anytime there's a negative involved, that's going to be reflection. Outside, again, is going to be a reflection vertically. So anytime you see the negative outside of the function here, here's our negative, that's going to reflect it vertically. And if you reflect vertically, you're going to be going over the x-axis. Here's our graph. So if you switch something here across the x-axis, that's going up and down, that's vertically. If it's inside the function, we know that's horizontally. So that's going to reflect it over the y-axis. Again, if you have something and it's here and you're reflecting over the y-axis, that's reflecting horizontally. All right, let's see if we can, just by the function, explain what's going to change the function from what we started with here of just f of x. All right, so the first one, a +4 inside of the function, it's inside first off, so we know it's going to be horizontally. And we also know that it's adding, so that's going to be a translation. It's going to slide it. Remember though, inside the function's always opposite. So usually plus would move right, but because it's inside, we know this is going to slide the function left 4 units. So it's going to be a translation left 4 units. The second one, I see two things here. We got this plus 7 and we got this minus. So two things are going to happen on this one. The plus 7, that's outside the function, so we know that's vertically, so that's going to go up 7. Now let's look at the minus. So that's going to be a reflection. Again, it's outside the function, so that's a reflection vertically. And if you go vertical, that's going to be over the x-axis. All right, next one. Two things again. We got a 2 here, and we also got a -8. The 2 outside of that, that's going to, it's being multiplied, not added. So that's going to stretch or compress it. If it's outside, it's what you normally think. So if you times something by 2, that's going to stretch it. So this is going to, that's going to be a stretch. The -8 inside, that's sliding because it's added or subtracted. And that's, remember, inside's opposite and horizontal. So that's going to slide it right, because it's opposite of what we normally do, right 8. And then our 2 over there is going to stretch by factor of 2. All right, next one. We got two things again. We got a negative and a 6. Negative is outside. That's so it's going to be vertically. That's going to be a reflection. Any negative is always a reflection. It's going to be vertically, so that's over x-axis. And then our 6 is being times, that's outside, so that's a stretch by a factor of 6. Okay, last one there. Why don't you, let's try it together. So this one, you're going to, again, look, this is both inside. The negative and the 3 are inside. That means you're going to be doing stuff horizontally and opposite of what you would normally think. So the negative is going to be a reflection. That's horizontally. Reflection horizontally is over the y-axis. And then the 3 is being times. Normally we would stretch, but this is going to actually compress this horizontally by factor of 3. And I suppose these last ones we should have been more specific. It's going to stretch vertically for these ones when we were stretching before. So make sure you, that should have a vertical there. Make sure you indicate which direction. All right, let's try some more out here with graphs instead of functions. So they will, given this graph of y equals x squared, which you've seen before, it's just a parabola. How is this parabola on the right transformed? Well, the shape appears to be the same, but two things happen. Looks like we, from where it started at the origin, we've gone up 1. We've also gone left 3 units there, so we have to adjust or account for that. And so when we're writing this equation, y equals, let's start with that shift of left 3. So if we go left 3, that's horizontal. That's inside our function. So in our function here, which is something squared, we are going to add or subtract on something. Usually, remember, inside's opposite. So usually going left would be -3, but because it's opposite, we would put +3 in here. Now, outside the function is our vertical. We went up 1. And remember, vertical is always what you normally think. So going up 1 would be adding a +1 on there. So that would be the equation for that parabola right there. Okay, next one. The equation of this graph over here is square root of x. On the right, what would that one be? I want you to pause the video and see if you can come up with the equation for this one on the right. All right, let's check it out. Looks like it got reflected over the y-axis. That's a reflection horizontally. That means the negative needs to go inside the function. So you should have had y equals square root of negative x. Okay, here's a graph of sine x. We've seen that wave before back in trig. The sine x starts at 0 here, goes up 1 and down to -1, and then it has a period of 2 pi, meaning it starts over every 2 pi on there. This graph on the bottom seems to have the same amplitude there. It's still going between 1 and -1, so nothing there's changed. But you see it has been compressed here. Now instead of taking 2 pi to complete a full wave, it only takes pi to complete that. So it got compressed horizontally. Horizontally, we know is inside the function. So this equation here is going to be y equals sine, not of x anymore. Something else needs to go inside that function to compress it. Usually when you compress, you divide something, but remember inside of a function's opposite. So if we want to compress it, instead of dividing, we actually want to multiply the x by something. So we got to figure out what should we multiply by. Well, how much did it get compressed by? It takes half the time now to do this. So if it was a vertical one, we'd put half, but remember it's inside, that's opposite. So instead of dividing by 2, we would times this by 2. So this should be y equals sine 2x for the equation. That would be the graph right here. All right, one last one here. This one wants you to actually graph it out and draw it. So why don't you pause the video and see if you can draw out what you think this function looks like, knowing that y equals x cubed looks like this. All right, let's see what you got. First, you got to figure out what are these things doing. That's going to move it up 1. We also have a negative in here, so that's going to, it's inside the function. So that's going to be a reflection. And it would be horizontally, which means over the y-axis here. So let's try this graph out. We know it starts here, or one point we know there's at the origin, it's 0, 0. That same point on this graph would be here. So if it was just the +1, and we got another point here, we know it goes through 1, 1, so up 1 over 1. If it just had, if it had just been the +1, it would look like this green one. However, we got to also reflect it here, so we also need to reflect this. So this point won't change because it's on the y-axis. That point would go there, that point would go there. So the final graph on this one should look something like that. So if you had a graph that looked like that, you nailed it.